This example in today's lesson, we are now on chapter 1, section 4. So today's focus is going to be all about the distributive property. So can we understand how to distribute numbers across parentheses and make sure we apply that to every term in our sequence? So these are our content standards for today. And let's get into some more of the work. So before, we've talked a lot about associative and commutative properties, all those things we wrote on the board earlier this week. Now we're going to move forward and work on applying the distributive property in as many ways as possible. This will help us to evaluate expressions to find out what are the value of these expressions. So we'll use the distributive property also to simplify and work through some examples. So some terms we'll see. Things like terms, simplest form, and coefficient. So we'll see those tossed around. Remember that coefficient is just a fancy way of saying the number that comes before your variable. So like 2x, the number 2 is the coefficient in front of the variable x. So keep that in mind. Okay, so we need to write down this definition if you haven't already done so. So what all these letters are really just saying is that no matter what you have on the outside, you can apply it to both terms on the inside. So this is a times b, which we see there, and a times c, which we see there. So no matter how this is written, you just need to know that when you have something on the outside of your parentheses, it can be applied to both terms inside of the parentheses. And that's how you multiply it out. You distribute that thing on the outside to everything on the inside of your parentheses. That's the whole point of the distributive property, which is what we're talking about today. So here's a real-world example. Now notice the highlighted box. You only need to write what is right there in yellow. So even though there's all those words there, we'll just talk about it and understand it. But for your notes, let's just focus on the shortest possible writing there to save us time. So let's rewrite that expression. Here, Suzanne is walking to school and home 5 days a week. We can look at the times and the distances and write that as an expression given. So it's 5 times the quantity, 15 plus 10. We can use the distributive property to rewrite that and then evaluate the total number of minutes that she walks to and from school. So if we rewrite it, we'll get one of those potential solutions there. And if we look at what the answer is and why that's the case, we can understand that it's 5 times 15 plus 5 times 10. Now, how did we get that? Well, this 5, if we want to distribute it, it's 5 times the first term, 15, which is here, plus 5 times the second term, which is here. So if we wrote all that out and multiplied it, our total amount of time she spent walking would be 125 minutes. How did we get from here to here? Well, we distributed that 5 to both terms. So that is how you solve these sorts of problems. So again, you only need to write this part that was in yellow, not the entire problem. The answer is given when we distribute our 5 to both terms. We get 125 minutes total. Now, example 2. We want to use the distributive property to rewrite this expression, 12 times 82, and then we'll evaluate it. So one way to think about it is to, instead of writing 12, we can break that down to 10 plus 2. And that'll make this something that we can multiply in our heads in a more simpler way. So the 82 stays the same. The 12 becomes 10 plus 2 in parentheses. We just break it down to make our multiplication more mental, make it easier to do it in that way. So then we could have 82 times 10 when we distribute, and 82 times 2. Using the distributive property, we can write it this way. So 12 times 82 is the same as 10 times 82 plus 2 times 82. We could, of course, multiply those, add them together, and we would get our final answer to be 984. Of course, you could also just multiply these normally as is, But when it says use the distributive property to rewrite it, they want you to rewrite it this way and break out the number in two different terms. So 2b, we want to use the distributive property to rewrite 6 times 54. So if we look at the possible answers, I know right away this one has to be wrong because this is 6 times 50, which has nothing to do with 54. So that one has to be wrong. Here we see 6 times 50 times 4. That's going to be a huge number. That's not even close to what we should be looking for. C and D, we have 6 times the quantity 50 plus 4. And we see that for both of these options here. This is what we want because 6 times 50 plus 4 is the same as 6 times 54. Why? Because 50 plus 4 in here is the same as 54. So this is 54 times 6. 54 times 6. So C or D will be right in terms of the expression. So which one of these values is correct? Well, if you did this in a calculator or if you wrote it out, you would find the total should be 324. So our solution to 2b is 324. Now 3a, we want to rewrite this expression using the distributive property and then we can simplify. So we start by writing what we're given and then we break this down, right? So we can apply this 12 to the y and to the 3. 12 times y plus 12 times 3. That's our distributive property. We're allowed to do that. So if we simplify, 12 times y just becomes 12y. 12 times 3 just becomes 36. So our final solution is 12y plus 36. All we did was distribute this 12 to both. And here we get that term, that sequence there. That is our algebraic expression when simplified using the distributive property. Now 3b, we can rewrite this expression using the distributive property as well. So we need to apply this 4 on the outside to every term in the sequence. So let's do that. We do 4 times y squared, 4 times 8y, and 4 times 2. Now all we have to do is simplify these things, and that'll get us to where we want to be. So 4 times y squared is 4y squared, 4 times 8 is 32, and 4 times 2 gives us 8. So now we have the whole expression. This thing here cannot be simplified anymore. Y squareds don't match up with y's. Those are two different terms. The 8 is just a number by itself. So that is our final answer for 3b. When written out, we distributed that 4, and we get this solution here. Now, 3c. We want to simplify this problem. So we distribute the 3 to every term inside this parentheses, and that'll give us one of the following solutions. So right away I know D has to be wrong because there's only one x to the third, and this should be 3 times 1x to the third, or 3x to the third. So anything that doesn't have 3x to the third is wrong. So D is wrong, and B is wrong. So right away I know it should be A or C. Looking at the second term, let's focus on our x squared. So how many x squared should I have? Well, I have 2x squared times 3. So my answer should have 3 times 2x squared, which is 6x squared. So the only answer choice here that makes sense is C. Those have the correct terms when we distribute that 3 to everything. Now 4a, we're going to practice combining like terms. So we have 17 times some number plus 21 times that same number. How many of those some number things do we have? Well, the distributive property allows you to rewrite that. So we take out what both things have. Both of these things have an A. We can put that on the outside. And we leave the numbers in parentheses and we sum them. So we can add 17 and 21. That'll give us 38. And we take the A and we just leave it there. It's multiplied. So this gives us 38A. So this whole thing here is the same as 38A. And we already know how to combine like terms, but the distributive property allows us to kind of prove that in a simple way here. So 38A is the answer for example 4A. 4B, we want to simplify this whole expression. How do we do that? Well, we combine things that are the same. We combine like terms. So 12b squared minus 8b squared, those two things are the same. We could combine those. Notice here what they did. What do both of these terms have in common? They both have a b squared. So we put that on the outside. On the inside, we have what's left, 12 minus 8. Now we can simplify this 12 minus 8. That gives us 4. So what are we left with? 4b squared plus 6b. And now we're done because b squareds and b's don't match up. That is our final answer for 4b. We use the distributive property to take out what's in common, simplify, and write that answer there. That is the conclusion for this lesson. So let's get started on our homework. You'll see that assignment on the board.